listen about solar cells and maybe not really much about this, but electrochromic devices. But how does it really works or affect our lives? Today, our friend Gaurav and I, we both are gonna make the science behind it edible for everybody. Así que toma pulque y come nopal, que el Pulque Podcast va a comenzar. It's my pleasure to welcome Gaurav to this space. Gaurav,
Thank you very
good
much.
morning.
Thank you very much. Good morning.
Gaurav, I know that you study chemical engineering
Yeah.
here in the department.
Yeah.
Can you tell us a little bit more about it?
Yeah.
More about yourself?
Yeah. Hello, everybody. Myself, I'm from India, and prior to join this department, I completed my studies in India, and right now I'm pursuing my PhD in chemical engineering from the in Professor Ho Research Group. So I'm working on electrochromic devices as he told, and I'm also working on solar cells, and I will be working in like some other kind of research field in my future. So yeah, I'm quite interested about exploring all those fields, and I'm happy that I'm here to discuss more about my research and try to like convey my research in edible form to people. Yeah, thank you.
Gaurav, as you said, you come from India. I know from northern India, and you speak many languages. I saw like
Oh, yeah.
Sanskrit
Yeah.
and some others. Can you
Yeah,
tell
yeah.
us about
Yeah,
the languages
yeah,
you
we
speak?
do. Yeah, thank you. Actually, we have like a lot of languages in India. People speak lots of language.
Yes.
We don't have a single language in our country, right? Like Chinese or like Spanish, like that. So we have 22 official languages in India, and I do speak Hindi. That is my native language.
Hindi.
Yeah, Hindi is my native language, which is the third most spoken language in the world after English and Mandarin, right? So yeah, I do speak Hindi, and I'm from North India,
Yeah.
obviously, because in India we are like, it's kind of North and South India. So I'm from Uttarakhand. I'm from to be
A lot of mountains
to be
over
precise.
there,
To be
nearby
precise.
Nepal, people.
Yeah. So it's near to Nepal, right?
Yeah.
Near to Nepal, Tibet border, and it's a border area. So I'm from Uttarakhand, and Uttarakhand is like kind of full of mountains, Himalayan region. So I'm from Himalayan region, and yeah, it's similar to Taiwan, because Taiwan also have like some mountains and mountain area, rivers like that. So yeah, I would say that I love Taiwan because it reminds me of my home place.
For sure.
Yeah.
I mean, who doesn't love Taiwan?
Yeah. Thank you. Yeah.
So, as I said, you speak Sanskrit or
We don't speak Sanskrit actually. We don't converse in Sanskrit.
yeah.
So because people used to do it in ancient times. In ancient times, they used
Sanskrit is an ancient language.
It's a very ancient and Asian language, very old language,
Yeah.
one of the oldest language in the world. And most of the languages in India are derived from Sanskrit. So Sanskrit
Okay.
was the original language, and like Hindi is derived from Sanskrit. So it's kind of a more easy form of Sanskrit.
yeah.
So a lot of languages in India, like I told you, 22. So out of those 22, I think almost every language is influenced by Sanskrit.
Yeah.
Every language, right? So
Including
it's a
the-
kind of a building block language, but we don't speak it because it's quite hard.
Including the other language that you speak, Garhwali or
Wow. I'm happy to hear that. Actually, Garhwali is a dialect.
Garhwali is
It's not a language actually.
Yeah.
We don't have a script, but it's my mother tongue.
okay.
Yeah, because when I speak to my parents, I don't speak Hindi as well.
Either English.
They don't understand English, and
Okay.
they can speak Hindi, but we talk in Garhwali. So Garhwali is my the native language, and when I talk to my friends, we talk in Hindi, right?
India is a place where you can
Yeah,
speak
yeah.
only
Yeah.
let's say you can not only speak 3 languages.
Yeah.
You gotta be speaking more because
Yeah.
India has how many languages? 400 something like that.
Man, yeah, I think around 700 is when you include all of them. Yeah, so a
All
lot
of
of
the
language.
dialects.
Yeah. It's too much. Yeah, everywhere in different. There are people like in India where we cannot talk to each other, so we need to talk in English. Like in my lab, there are two postdocs from India, but we cannot talk in our native language, so we have to talk in English, right?
Yeah.
In my lab. But I can talk to a Pakistani guy in Hindi.
Oh.
Yeah, because
Interesting.
right in Pakistan and in North India we speak the same language, but
Yeah.
in South India the language is different, right? So it's kind of that kind of thing is there. Yeah,
Sure.
yeah.
And how about university?
Oh,
Your bachelor's degree, did you
Yeah, yeah,
study?
yeah.
I mean, when you were studying
yeah,
chemical
yeah, yeah, yeah,
engineering,
yeah.
did you study it in English, Hindi?
Oh, okay,
Or
okay.
which
I-
language?
okay.
Tell us a little
oh,
bit
yeah,
more of
sure,
your-
sure, sure, sure. Thank you very much for your question. Till my high school, I studied in Hindi.
Yeah.
I studied in Hindi till my high school. But when you goes to engineering in India, you have to study in English.
Okay.
That is the only medium you can do
Yeah.
in engineering, because I'm chemical engineer. So I have to learn in English. So I did my bachelor's in English from Uttarakhand,
Yeah.
my place, right? And then I did my master's from Indian Institute of Technology, IIT, very famous institute across the world.
Okay.
IITs are very famous for, especially in US, they are highly regarded because most of the IITians are running their businesses like Microsoft. Even the CEO of Google, he's IITian. He's
Oh,
from
really?
IIT. Yeah, Sundar Pichai.
Okay.
Like you take CEO of Google, Adobe, and like any big giant companies, they are like IITians. Sun Microsoft in US, so IITians have like that kind of reputation. So
Yes.
I'm proud to be from one of the alumni of IIT. Yeah.
And then right now,
Yeah.
after your master's, you came here to Taiwan
Yeah,
to join also chemical engineering
Yeah.
department
yeah.
with Dr. Hall.
Dr. Ho, yeah. Actually, I would like to talk more about it.
Okay, well, maybe we can start talking about electrochromic devices.
Yeah, sure. So actually, I wanted to have my PhD degree from some top university, and I wanted to go outside India to just
Yeah.
explore the things. So in that regard, I applied to different universities actually, and I also wrote to Professor Ho about my interest to pursue research in his lab, and I think he's very humble,
Yeah.
and he like replied me in a very humble way that okay, you are welcome. You are from IIT. I would like you to join my group, and I also got a scholarship. So I just end up by joining his research group, and I think I'm enjoying it.
Yeah. Great.
Yeah.
So, you are doing research with him about solar cells and
Yeah.
electrochromic devices.
Yes, actually, electrochromic devices is my main
Main.
research topic right now. But I will get into solar cells later. Yeah.
What are those devices?
Okay, so I will put a brief introduction of electrochromism first. What
Okay.
is electrochromism? So electrochromism is a phenomena where any material changes its color when potential is applied to it.
Yeah.
We put a potential to it, and it will
An
change.
electrical potential. not
Yeah,
voltage.
yeah, voltage, and it will change its color, right? It can change to any color, right? So we utilize those devices in different things, right? Like sometimes in sunglasses, right?
Yeah. So
Have you seen those glasses when sunlight is there and they will turn into kind of black?
I think
Right,
everybody knows.
right,
that.
yeah, and yeah, like, everybody knows
Yeah,
that.
yeah.
We all know that, right? So they are electrochromic devices,
Yeah.
as simple as. And in mirrors, even in aeroplanes, right? There's an aeroplane, a Boeing 787 Dreamliner. So
Yeah.
that aeroplane uses those electrochromic devices.
The electrochromic device, specifically electrochromic window,
Window.
it's when you have like a glass and you apply the voltage
Yeah.
and it turns like let's say it can turn opaque or more transparent
Yeah.
or change color.
Change color. They can change
Yeah.
color. So generally they have like only monochromatic devices. So these monochromatic devices will change into a single color.
Yeah.
Like it's transparent, and when you apply voltage, and it will turn into like yellow or green
Okay.
or kind of like gray, like that.
Are those voltages very high?
No,
Okay.
they are not very high. I mean, there's a small range.
Small
If
range.
we need high voltage, then the device is not good. It simply means
Okay.
the lower the voltage, the better the device. the
For
higher,
sure, the
yeah,
better
yeah,
efficiency.
the better efficiency, higher the voltage, the device is not good.
Yeah.
So we need to think about all those things. We have a specific window for voltage. If it's going too high, then it's not. And also the second thing is stability of device. How long it can change color?
Yeah.
Like if it's working for only like 10 days or like it's working for only
Okay.
20 days, it's not good. We need it for years.
Yeah, of course.
We need it for years. In airplanes, in your window, we cannot change our windows like in every month, right?
It sucks.
So, so it sucks. So the stability is our main concern actually.
Yeah.
And my research group is very much focused on the stability of those devices.
Yeah.
We want to make them stable, right?
Yeah.
Like it's changing color, that's good. But it's not changing or it's not working properly after 30 days, or it doesn't work. So that way. So
And what are those materials? I know it's tungsten
yeah,
trioxide.
yeah. So tungsten trioxide was one of the first material.
Okay.
And actually, there's a very interesting paper of Asdev. Asdev is a chemical engineer, and he was the first who used that material, tungsten trioxide.
Yeah.
And his research paper is still considered the groundbreaking research paper, and that founded the way to those color changing materials. So we were talking about electrochromism, and you were asking about what kind of materials we use. So these kinds of tungsten trioxide, and there's a different kind of materials like viologens I'm working on, and those materials change. Oh, it's a kind of chemistry, complex chemistry. So we have different kind of materials.
Yeah.
They change their color when applied to some certain voltage. So we are using currently to make them commercial, because a lot of materials cannot commercialize.
Yeah.
We are using
Because
them
of the price.
because of their price, and also because of their their fabrication, and there are some challenges in every device. Every challenges are there.
The challenge in fabrication, what would it be?
Okay, so we have a lot of challenges. The first thing is that we have different kind of electrochromic devices, like liquid type devices, like sometimes liquid type. So you will put a kind of liquid inside your device, right?
Yeah.
So
Inside a window. let's
inside the window, right?
Yeah.
So that will be a liquid, but liquid can come out. It can emit sometimes,
say.
right?
Evaporate, maybe.
It can evaporate, and sometimes the non-homogeneous distribution, like
Yeah.
somewhere the liquid is not properly like
Distributed.
right? It can happen somewhere. It stuck inside the glass somewhere, and
Yeah.
right like that, and it's not. So there are challenges. Also, the solid devices, they have different kind of problems like stickiness and all those things.
Okay.
Right. So we want to make the devices like they should be also they should be like commercially okay. They should be commercially fit to our demands. It should not be like that. We did something in lab and we think it's okay. When we go to commercial scales, the things are very different. So we need to also think about those aspects. Yeah.
And those challenges are stopping like the technology like to improve, right? Because I know some companies want to use electrochromic devices for phones. So you can like your phone is gonna be able to change color when it has a battery, so you don't need to turn it on or just see it how it changes.
Oh yeah, they can be used, but I think in phones because we are already using some other kind of screens in phones. So I don't know how big impact they will have on phone industries. I'm really
Yeah.
not sure because
Maybe
because
some years later.
because right now the more focus is on like Windows, but maybe in future, as you told, yeah, it's possible. But right now, most of the people are using, most of the companies are trying to get them in window purposes. Window
Window
purposes,
purposes,
yes.
okay.
They are the main concerns of, yeah.
And
Yeah.
then you just said in window purposes, so it
Yeah.
would be in the architecture industry.
Yeah, yeah.
Okay.
Yeah, because, yeah, it's just,
Architecture is something I think you are working a lot on it because solar cells, solar panels, I mean, they should be in houses, in like buildings,
yeah.
and these type of windows too.
Yeah.
Right?
Right.
So
right,
this is what brings us to like the next topic you wanted to talk about.
Yeah. Solar cells, right.
Yeah.
So solar cells is also one of the topic I'm interested to talk about. Why? Because in solar cells, my research group is rated very high.
Yeah.
Actually, it is third in the world.
Okay.
Yeah, it's third in the world after Amgresil group, and there's one more group who are famous who invented actually a special kind of solar cells, and then my group is there, Professor Ho's group.
Yeah.
It's very famous. So, okay, so first I will try to introduce some brief things about solar cells.
Sure, please.
So solar cells are like materials or devices which uses like sunlight to produce electricity, right, or for daily use. So we have been using solar cells for decades, but now because we are going into a new, like we are moving towards new future, we need different kind of new types of solar cells which are more efficient and which are less costly, right?
So you mean the solar cells and solar panels right now are not that efficient?
Actually, the problem is that they are not that efficient as the conventional one,
Okay.
right? At the conventional one, but the problem is that the conventional one is costly. It's costly, but we don't want to use that much of because we are money centric, everything like
Yeah,
the
of course.
industries or everything. So we don't want to use those conventional devices. Now we are heading towards new types of solar cells. So the conventional solar cells are known as the first generation solar cells.
Okay.
Okay, so we are using in our like rooftops and those silicon solar cells. But right now we are working on second generation and third generation solar cells. And what are they? They are actually thin layer solar cells. We call them thin layer solar
Okay.
cells. So they use thin layers, very thin layers of solar materials to get the sunlight into the electricity.
Yeah.
And second generation solar cells use one layer, one monothin
One
layer.
layer.
But the third generation they use multi layers.
Okay.
Yeah. So the DSSC, dye-sensitized solar cells, my research group currently working on that. It's a third generation solar cell,
Yeah.
DSSC, and extensively used, extensively researched across the world, and people have worked on its efficiency. But as I told you earlier, that it's very difficult to increase its efficiency even by 1%.
Very difficult.
Very difficult to because people have already researched so much, so it's very hard even to increase. Like if someone can make it to 0.5%, 0.4%, that would be, I think, it would be a breakthrough. It would be a
Okay.
breakthrough. Yeah. Oh, so yeah, big price.
Yeah,
Big price
because
is there.
if you open that door, it might
Yeah,
open
yeah.
some other doors behind.
Exactly.
Right?
Exactly.
So the usually solar cells are just the tiny cells
Yeah.
inside of a solar panel.
Right.
So
right.
these solar cells,
Yeah.
what are they made of? Like usually.
They're made okay. So they're made of different kinds of materials. Okay, so in solar cells we have two kinds of substrate where different materials are there, and in between we use some materials like in dye-sensitized solar cells we use dyes. We use dyes. That's why it's dye-sensitized solar cells. And we also use some different kind of it can be like silicon sometimes,
Yeah.
right? Silicon, because silicon is a semiconductor which uses there. So it's kind of mixture of different materials.
Yeah.
And researchers are trying different materials. Sometimes combination of those materials to see their effect, how they are working in a combination.
And no matter the material, we always need to have, let's call it the type of material that has an excess of electrons, and the other one that has, let's say, less electrons. Right?
Yeah, you can say that. Yeah,
So when
we can say that. In layman's term, like we can say that we are looking for those materials which can excite more electrons, so because we need them. So yeah, and also they should be compatible with the other material that we are mixing with them. Right? So like that. Yeah. So it's like a lot of technicalities is there, but I will say that. Yeah, you're right that we want those kinds of materials which can emit more electrons.
Yeah, but let's explain a little bit more the process.
Okay.
And so, solar light comes to the
Okay.
solar panel.
Okay. So so they work on photovoltaic effect actually.
Okay.
Right. So what is photovoltaic effect? It's when sunlight comes to any material, like silicon and any semiconductor or any material we are using. So that material will emit electrons. It will emit electrons. Yeah,
Make it
because
exciting.
it will make the electron excite from their like lower states to higher states, right?
Yeah.
So that will get energy and that will get excite. So when the electron leaves, it's like it will leave its territory, or it will be excited to some higher stage but will not leave its territory. So on the basis of that, we will say it photovoltaic or photoelectric effect.
Okay.
So there are two terms: photovoltaic effect and photoelectric effect. But both are like, we utilize them for like electricity, right? So there are
Okay.
some, but yeah, it depends how, if the electron get out from the territory or not. So solar materials works on this principle, right? Photovoltaic effect, and they will use the sunlight. So this is the main principle of all the solar cells. So we just make the like. So what do we change and what we are doing
Yeah.
if the principle is same? So we are making change with the kind of materials we are using. So initially we were using silicon material, like conventional material, but now we want to use different materials, which is more or less costly, right? It's
Yeah.
less costly, and which can give us the same kind of efficiency
Okay.
at less cost. So that's why we are like heading towards second generation, third generation, and maybe in next decade we will use fourth generation solar cells like that.
Yeah.
Yeah. And it's very important. It's very important because the major demand in the world currently is energy demand.
For sure.
Energy demand is a very major demand. So they all are fulfilling our energy demands. And if we could achieve some breakthrough efficiency, I think the most of the energy demand of the world would be met.
Yeah, for sure.
So it's very important. Solar cells are really important if someone can make a breakthrough.
And why are them like blue color? Why the solar cells
Okay,
are
okay.
always blue color?
Okay, so the color is all about your like wavelengths, right? Color is all about wavelengths and our visibility, right? So we can see the color because we can see the visible range, that is like 400 to 700 nanometers.
Yeah.
So so if there's a blue color, there's a particular wavelength which is
Yeah.
which it is like emitting.
Yeah.
It's emitting, and that color we see. So every kind of like all the materials have different kinds of absorbability, transmittance, right? They can absorb some special kind of wavelengths, and they can reflect.
Of course.
They can reflect some other kinds of. It's an intrinsic property of a material.
Yeah, like right now, the
Yeah,
light.
the
we
wall
are
is like white, so
reflecting-
it's this wall is reflecting everything.
Yeah, for sure.
You're black, so it's absorbing everything. So so yeah, it's intrinsic property of a material. So yeah, that's why it's blue, because they generally reflect the blue range and absorb the others.
So the solar cells are blue because of they don't reflect those photons, that light,
Yeah.
so that the solar cell can absorb the solar light
Yeah.
and don't reflect it.
Yeah,
So that is something very
Yeah,
important
yeah.
for
Most of the
efficiency as well.
efficiency, efficiency is actually a different thing, but yeah, their absorption range is a thing which makes them blue color. But all of them are not necessarily blue. Sometimes,
Okay.
sometimes they may have different color. It's all about visible range color. But yeah, most of them are blue for sure. Yeah, which we have seen in different images everywhere. They're blue. Yeah.
Okay.
Yeah.
And then they have like a type of like a ceiling, like a cells.
Yeah.
So
Yeah,
those ones are also made of silicon, right?
yeah.
For
And
the
those,
heat.
those are made of silicons, and sometimes same kind of semiconductor material, and we use them in bulk. We use them in bulk
Yeah.
because we need a good amount of electricity, right? So if we use only one solar cell, it won't work. We need a bundle of solar cells
Yeah.
in a frame, inside a frame, which we have seen. So we see a lot of put together, right? And then we get like sunlight, and we will convert them. So yeah. I think
In how long time, like, I ask you because you are researching about this, in how long time do you think that the fourth generation cells,
okay.
solar cells might come, or what's the future that you see for this,
Okay.
for this research,
Okay.
and let's say for this business, right?
Yeah,
Because
yeah.
as you said, It's the money generation.
Yeah, yeah, it's money generation for sure. Okay, so I think for the fourth generation is like, I think it's not like that because scientists they assume that they are working on third generation. It's
Yeah.
nobody's there that who will come and say, okay, so this one is the fourth generation, and nobody will announce like that. It's kind of a mutual understanding between researchers.
Yeah, for sure.
When they are like working on a special material, then they will say, oh, it can be considered. But when someone comes with a new breakthrough or new kind of material or new kind of idea, maybe that would be the inauguration of fourth generation.
Yeah,
solar
like
cell.
the time lets you
Yeah.
settle
Yeah, yeah.
the different type of generation.
Yeah, because when someone changed from like the first generation to second generation, so what was the change? It was not about the years, like 10 years and it will be the fourth generation. It was about the material.
Yeah, for
They
sure.
were using silicon and then they told, no, we can use thin film material. So
Yeah.
it was a leap from first generation to second generation. So
So first generation ones were
Working
a little
on-
more thick.
yeah, thick and conventional, right?
Conventional.
That silicon one.
The
And they,
second one?
the second one, they told, no, we will reduce the cost. We will reduce the
Reduce
cost.
the cost.
Yeah, and we will use some other materials.
Okay.
And they use thin materials. The second and third generations are working on thin film materials.
Yeah, yeah.
But maybe someone in the fourth generation, some researchers, they said, okay, we will reduce the cost as well and we will increase the efficiency as well. So that would be considered as fourth generation.
Yeah.
I think. So
And fourth generation, I think, is gonna be a challenge as well because
Yeah.
we have limited amount of elements.
actually,
So
actually,
it's not like a
actually, the research has become more difficult, I think,
yeah.
right now because everything has been searched. Sometimes
Maybe
it thinks
we can look for new physics.
but yeah,
that is
so
the-
we need a like when I talk to my professor, so I discuss with him. So professor who told me that okay, you can work on solar materials, solar cells, but I would like you to like work on some other things because it has been extensively researched.
yeah.
Like people have done everything almost which could be done in research labs. They have tried most of the things. So we need some breakthrough to break this barrier and leap into some, right? So another one because like we have like a huge team of resources in the world right now because research has been a very widespread thing in the world. It is not like that 50 or 60
That's
years ago.
great. That's research is growing. The more research grows,
So like
the
that,
better.
yeah, the better. Everywhere they are working, so it's difficult to like think something because people are constantly working on that.
Yeah.
Yeah.
And then, may I ask a little bit crazy question?
Mm-hmm.
Could you make a electrochromic device,
Mm-hmm.
let's say an electrochromic window,
Yeah.
that is also a solar panel? Let's say an electrochromic device that, I mean,
Yeah.
you just told us that it needs an applied voltage.
Actually, yeah.
Let's say one that with light it gets charged.
Yeah. Actually, that's not a crazy question because
Okay.
it's been researched.
Yeah.
People are already doing that actually. So your question is a very like logical and very logical question actually, because why don't we use those solar cells to get voltage
Yeah.
and that use that voltage into electrochromic devices? That's right. So people are doing that. Even my research group has done that. Okay, but the problem with there are challenges. Obviously, there are challenges, but while we are doing that, because while we are doing it, we need to incorporate DSSC and electrochromic materials in a SEM device,
Yeah.
right? So it's quite complex, and then we need to think about the physics and chemistry of those everything like material and to okay. The problem with the solar cells are all the time the sunlight cannot be with of same intensity, right?
Oh, of course.
Right. Okay. So when we are applying a potential, so we know that we are applying like 0.6 or 0.5, but when you are using sunlight, you are dependent on sunlight, right?
Such as in what you were telling me about the electrochromic devices
Yeah.
during different type of,
Yeah.
let's say, time of the year.
Yeah. Time of
So
day.
I'll let you keep on
Yeah,
saying.
like in electrochromic devices we discussed. So it's difficult because when we are making devices, we need to take care of the all kinds of climate in the world. Suppose we make a glass which is used in Russia in the temperature of -15, -20,
Yeah.
and we have made this glass compatible to the temperature of Taiwan at 35 or 30, and it's not working there, right?
Yeah.
So we need to take care of the temperature ranges. That if the
Temperature, pressure,
pressure,
humidity.
right, humidity, everything actually. So it's not that easy actually. We need to take care of all because if we are going to commercial level to commercialize our product,
Yeah.
we need to take care of everything actually. We need to take care of everything. Otherwise, we will not be successful, obviously.
Yeah, of course.
So, yeah. So, these are the concerns. There are some thermoelectrochromic materials.
Okay.
Thermoelectrochromic materials. So, they will change their color according to temperature. When they are above a certain temperature, or like 60 or 80, they will change their color. But the problem is, where would you get 80 degrees centigrade in the world? You cannot live with that temperature, right? So, yeah. So, these are the problems we need to deal with, yeah.
Let's don't challenge nature, because
Yeah.
nature can make something
Yeah.
evil in,
Yeah.
in very extreme places.
Yeah. So, these are the things, yeah.
So that thermochromic device is used to, like, let's say in winter,
yeah.
it's a window that during winter it lets more solar like energy, solar light to pass through. So
Yeah.
your room, your house
Yeah. We
gets
can
warmer.
we can use that.
And then
yeah.
in
In the summers,
summer,
we can block sunlight.
it blocks sunlight,
Yeah,
so it doesn't
we can
get so
block.
hot.
Yeah, it necessarily doesn't block it. We can make them like do it, right? We can make it do
Make
it.
the
Yeah.
resistance high.
Yeah. We can like we can fabricate it
Yeah.
according to our demands. Yeah.
And right now, what we are talking is mainly process integration, right?
Oh wow.
To
That's
integrate, like,
yeah. That was
different
actually
type of things.
I told you this topic. I will discuss about it because it was my master's studies topic.
Okay.
I did my master in this research area. and
Process integration.
Process integration. So I'm very happy actually. This field is core chemical engineering actually. Process integration is the core chemical engineering for which chemicals engineers are meant for.
Why do you think so?
Okay. Because chemical engineering, when I talk about electrochromic devices or electrochromism, they are more chemistry is involved there. More chemistry. Materials and their behavior and their just synthesize different materials. But when it comes to process integration, it's core chemical engineering. No chemist can do that. Only chemical engineering.
Chemical
can do that. Yeah,
engineers.
process integration. So what chemical engineers do actually? We chemical engineers, we design, right? We design and we scale up and we make a plant run, right?
Yeah.
That's what we do. We optimize that plant. We use everything. We use mathematics, we use biology, we use economics, everything.
Physics.
Right, physics, we use physics to make the things more optimized. That's what we do. So, so process integration is all about doing so. So it makes a lot of process integration engineers in the world, they are doing like what they are doing. Process. Okay, I will try to summarize it
Sure.
in a very short words. What process integration is. So suppose in a chemical plant, or suppose in this room, we are using 5 or 6 LEDs, 5 LEDs to light this room for this much of light,
Yeah.
or a certain amount of light. But I want to get that certain amount of light with 4 LEDs, not 5 LEDs.
Okay.
Okay, so it will like reduce my cost, obviously.
Yeah, of course.
Right. So that is what process integration is made for.
Okay.
That's as simple as that, I can speak. So suppose in a plant we are using 10 heat exchangers and getting some amount of work output and getting some like product, but I don't want to use 10. I want to use 8.
Yeah.
So I want to reduce the cost of 2 heat exchanger. How can I do that? I can do it through process integration. So I will try to design the plant with that way. To retrofit, we use the word retrofit, to fit
Yeah.
it again in such a way that 2 heat exchangers, in a combination of heat exchangers, that they will use only 8, but the production will be same.
Yeah.
So this concept was actually, I'm very interested to tell all my peers and my colleagues that why this is very important for our chemical engineers, because the first person who brought this idea was Linhoff. His name is Linhoff, Bodo Linhoff. He was a PhD student.
Yeah.
And he was doing his PhD in UK, I think, and he introduced this idea that we can save a lot of energy or a lot of money in a plant by doing this. A lot of energy we can save. like 8 heat exchangers and 10, right? So in a plant, we are using thousands of heat exchangers. We can save a lot of energy. So he introduced to his supervisor, and his supervisor could not believe that, oh, how can it be possible? But finally, he made him convinced that, okay, we can do it. And they submitted their work to top international journals, but they refused to publish.
Really?
Yeah, they felt it's crazy idea. It's crazy. They simply declined. But finally, American Institute of Chemical Engineers published his research. And it was a groundbreaking research, actually. This research got Millennium Prize. I told you.
Yeah.
I told you about Millennium Prize.
Yeah,
so
sure.
this research got Millennium Prize. His publication got Millennium Prize. And he was appointed a professor at University of Manchester at the age of 33. Full professor, just because of his research.
Yeah.
And there's a process integration center in University of Manchester, which is very famous all across the world. Every process integration engineer want to go there. So I tell to my colleagues, if you want to learn more about process integration and do research, just go there. University of Manchester, very famous.
Gaurav, do you want to go there?
Because right now I'm doing my research in different field. So
Otherwise,
I
you
think-
would go.
yeah. So,
Okay.
but someone who is doing their PhD, it's a great center.
Yeah.
50% of the world publication comes from that university center.
Okay.
A lot of top pioneers are working there.
Another question about I want to make you. Would you like to go to Colombia?
I would like to.
Why?
Okay, because I think so Colombia. I have heard about Colombia. It's one of the big country.
By which author, let's say?
Okay. Right now, I'm reading 100 Years of Solitude. It's
Great
this book.
Great book.
Salman Rushdie is an Indian author,
Yeah.
and he's a very famous author, Salman Rushdie. And he said that 100 Years of Solitude is perhaps the best novel written in any language in past 70 years. In any language, right? It's a very, very big statement. And that statement made me to get that book. And
By Mr.
and then I read about Gabriel Garcia Marquez, and I was fascinated by his life. Do you know when he wrote this novel? He took 18 months to write this novel, and in that time period, he was like, he made him like home arrest. He didn't go outside his home.
Yeah.
He told after writing that I at least smoked 30,000 cigarettes when he was writing that novel. Even
He
crazy.
was like a quarantine guy.
He
You
was a
see?
crazy guy.
Right, another 1,000.
And he was like that kind of in poor situation,
Yeah.
financial crisis that when he completed that novel, like it I was like very emotional when I read that when he completed the novel, when he wrote the manuscript, he didn't have enough money to submit it to the publisher.
Absolutely.
And then he submitted when like he
He
arranged
said
some money.
The very last.
He arranged, and the very last time he could manage it. But when the novel got published, it became it became one of the greatest actually. And I think when he died, Colombian president said that he was one of the greatest Colombian ever born.
I think he was
Marquez,
one of the
yeah.
great humans.
I think his writing is actually.
Don't put nationality.
Yeah. It's even Nobel Prize. It's like Spanish and everything. Yeah, he has a very huge influence on everything. I think he has a very, right? Even in Mexico, right?
Sure.
He had many he had house in Mexico, I think. So he has, because Colombia and Mexico are very like nearby, right? I think
not that close, but
Panama is in between.
Panama, Costa Rica, Guatemala.
Costa Rica. Okay.
Yeah.
They are in between. Okay. Yeah, but this author.
Gaurav, thank you very much for
Oh,
coming.
thank you very much.
was a pleasure.
Thank you very much for inviting me. Actually,
you.
I enjoyed it. Yeah, thank you.
Great. Thank you very much for watching this episode. Like the video in case you liked it, and leave a comment below for further improvement of our content. As well, if you like topics such as new technologies, research done in universities, or even wonderful stories of incredible people, subscribe to our channel. This is how you find us in social media. I want to give a special thanks to all my sponsors and team members. Y recuerda, toma pulque y come nopal, que la próxima semana otro video.